Good day everyone. Today I will be presenting my research idea which focuses on the design and evaluation of gamified physics instruction to enhance students' engagement, manage cognitive load, and support effective learning outcomes. By Jimoh Abdulmalik and Adekunle, Master Degree students, the Department of Educational Technology, Faculty of Education Science and Technology, with ID number MHP242019. So this is the background of the study. Physics is perceived by many students as a difficult and abstract subject. In particular, topics such as electricity and magnetism. Many students experience low engagement and cognitive overload when learning this concept through traditional instructional methods. So with the increasing use of mobile technologies in education, gamification has been proposed as a promising instructional approach to improve students' motivation and engagement. Notwithstanding, there is still limited empirical evidence on how specific gamification techniques influence students' engagement, cognitive load, and learning outcomes in physics education. So the purpose of this study is to design and develop a gamified physics instructional application, which is going to be grounded in self-determination theory, and the development will follow the RGE instructional design model. So we have to examine how this gamification influences students' engagement, cognitive load, and learning strategies in physics learning. These gamification techniques are the adaptive int, badges, and narrative int. This study has four main research objectives. First, it aims to design and develop a gamified physics instruction based on self-determination theory. The second part is that it seeks to examine the effect of gamification techniques on student physics learning outcomes in terms of engagement and cognitive load. The third part is that the study will investigate how student experiences with gamification techniques influence their relationship between gamified instruction and learning outcomes. And finally, it will also explore the influence of student gamification experiences on their engagement and learning strategies. So, in order to address these objectives, the study is going to be guided by three research questions. The first one is that to examine the effect of gamification techniques on students' engagement and cognitive load. The second question is to investigate whether student experiences with gamification techniques influence the relationship between gamified instruction and physics learning outcomes. The third question is that we are going to explore how students' gamification experiences influence their engagement and learning strategies. The intervention for this study is to create an Android-based gamified physics learning application. We'll be focusing on electricity. The application will include features such as drag and drop circuit builder, where the student will be able to drag and drop the circuit components to either light a bulb or collect a wrong connection. So there will be real-time feedback on circuit accuracy. There will also be unified challenges and quizzes with progress tracking. And all these features will be designed based on a self-determination theory, which will support student autonomy through exploration, competence through immediate feedback, and challenges and relatedness through structured learning progression. As I said earlier, the design will be made with MIT App Inventor, and there might be an SQLite for database management. So it will be storing the student interaction and their login and logging out. The study will adopt a mixed method design for both qualitative and quantitative approach, using the quasi-experimental and the correlational design. The population of this study will include 60 grade 10 secondary school students that are enrolled in physics class with gamification-based instructional strategies in the selected school. And these students will be selected based on the purposive sampling, and they will be grouped into two, each containing 30 grade 10 students per group. One group will be experimental and the other will be control group. The data will be collected using a student engagement questionnaire, a cognitive load questionnaire, a gamification experience questionnaire, and a learning strategies questionnaire. And the data that was collected will be analyzed using SPSS, following the descriptive statistics, regression analysis, and the regression analysis. Also, there will be a Pearson correlation analysis to find the relationship between the variables, and the qualitative analysis will be used to buttress to support the quantitative analysis using thematic analysis. In order to ensure coherence in the study, an alignment table is developed to link each research question with its corresponding objective, instructional instrument, research instrument, data source, research aspect and focus, and data analysis. The expected findings is based on the previous research, theoretical presumptions of self-determination theory, and cognitive load theory. It is expected that student engagement should be improved when exposed to gamification techniques, leading to a better physics learning outcomes. In conclusion, this study aim is to contribute to physics education by providing empirical evidence on how gamified instruction can enhance student engagement, manage their cognitive load, and support effective learning strategies. The findings thereafter are expected to benefit both educators and instructional designers in implementing gamified learning approaches in physics education, and also help the government in providing necessary policies to support physics education. Thank you all for listening.